Module 1, Topic 2, a review. I know it says honors, but we're going to do, this includes on level as well. Which sequence of transformations will carry the given pre-image onto the image shown with the dotted lines? So we could potentially, I'm just gonna outline this so y'all can see what I'm trying to say. We could potentially rotate, okay, that's not exactly what I was going for. We could rotate this about point C. So rotate triangle ABC 90 degrees, and that was clockwise. About C. Then, so after we do that, we would then have to take this triangle and translate it. So it would just be a translation. Okay, so then translate. And to kind of, I guess, indicate where the translation would be heading, we would go in this direction. So from C to C prime. So translate from the distance from C to C prime, or we could just write C prime like that. So I'll put that in parentheses. Okay. All right, so for number 2, we're trying to figure out which one will not carry. Go ahead and try that on your own. Number 3, what kind of rotation would change the pre-image to the image? So what kind of rotation? So it's supposed to be a rotation. So I'm gonna look at it this way. And if you're using paper, then you could use patty paper to do what I'm doing with the select tool. So I'm just gonna select this. I'm gonna rotate it. Oh, that was silly. Hold on, let me put the letters. The letters are really important because that way you can tell if it matches or not. All right, my bad. So we're gonna rotate this way. You can see that's 90 degrees clockwise. Does it match? Yes. C matches with C, A with A, B with B, D with D. Okay. So a 90-degree clockwise rotation. Something else that could work, and I'm sorry, hold on. Let me do all of that again. So 90 clockwise would be the same as, let's go counterclockwise. 1, so that's 90, 180, 270. And as you can see, the letters still match up. So we could do that or a 270 counterclockwise. Rotation. All right, go ahead and try number 4 on your own. Number 5, write an algebraic expression or representation that indicates reflecting a shape over the x-axis. So x-axis needs to go first, reflecting over the x-axis, then translating 5 units up and write 6 units. Okay, sorry, brain fart. So when we start, we're always going to start with the original x comma y. And to do a reflection over the x-axis, the y will change. And you need to use your formula chart, the transformation formula chart. And then to do a translation of 5 units up, that'll be y plus 5, because up is a y change. And then right 6 would be an x change. X change. And there you go. But we're going to make this a bit more concise. We're going to change both. We're going to do the change in one step instead of doing it in 2 separate steps. So if I wanted to show that in just one step, okay, the x went from staying the same to adding 6. So we can just put that together and say that we added 6 to x. For the y, we did change the sign of y first. And then after changing the sign, we added 5, so we could just put plus 5. And that is what we are going to rock with. Go ahead and try number 6. Same situation. Number 7, ABC is transformed to create DEF. And, sorry, just checking. Okay, what sequence of transformations maps one onto the other? So we see here that A is supposed to match with D, B is supposed to match with E, and then C with F. So keep that in mind. So let me highlight that. Will this help? I don't know. We're just trying stuff to see if that'll help us keep track of everything. Okay. As always, I'm going to outline the original. And again, you can use patty paper to do this if you are working on paper. So the first thing that I see here is that it's flipped, because as you can tell, the purple went from this side to this side. So there is going to be a rotation of some kind. When I say flipped, I mean turned, I'm sorry. So let's start by rotating this way. Okay, it does seem to match. Okay, so we have a rotation. That was a 180-degree rotation that I just did. So 180-degree rotation. And that could be clockwise or counterclockwise. You're still gonna end up in the same place. So let me go back so y'all can see that. Oh, never mind. Okay, so let me do this. Okay, so let's go back. All right, so if I go clockwise, counterclockwise rather, it ends up like that. And then if I go clockwise, it still ends up like that, either way. All right, so after we rotate that, we're gonna need to translate. So hold on, let me do this a little bit more accurately. I'm gonna select the whole thing, and then we're gonna rotate 180 degrees. Okay, great. So it ends up here. Then after we rotate 180, we're gonna need to go to the right. So that was 2 to the left, I'm sorry, 2 to the left. Okay, struggles. Okay. And I'm sorry, this was about the origin. So the origin, 0, 0 was our center of rotation. Sorry about that. Okay, so that's it. Go ahead and try number 8. Number 9, the image in this figure was formed by reflecting triangle GHK over the y-axis and then over the x-axis. Write congruent statement for all. Okay, so it doesn't really matter what the transformation was. We just know that there are symmetries, meaning that the shape didn't change, the size didn't change. So, actually, it kind of does matter because we need to figure out which parts are the same. I mean, you might be able to kind of look and tell, but for the sake of being safe, that's an M, that's a P, that's an N. Oh, my bad. Let me do this one. Hold up. Okay, sorry. So this was the original. And I'm doing this so I know which parts match up. I mean, like I said, I feel like it's kind of obvious, but we're here. All right, so if I rotate this thing 180 degrees, I end up there, which is the same thing. Oh, sorry, we're not supposed to be rotating. We're supposed to be reflecting. Okay. So if we reflected this across the y-axis first, it should end up here. She is there. So this would have been H prime, G prime, and K prime. And then you can see which parts are supposed to match up now. I feel like it's easier to see which parts match up. So M and G are congruent. So angle M is congruent to angle G. And then angle P and K are congruent. So angle P is congruent to angle K. And N is congruent to H. So angle N is congruent to angle H. And we could put it like that, or if you want, we could put the original one first. It doesn't really matter. Congruent is congruent, equal is equal. And then for the sides, we can see here that HK matches up with NP. So HK is congruent to NP. And then KG is congruent to, so KG is congruent to PM. And then HG, oops, forgot the lines. Segment HG is congruent to segment NM. All right, so those are all your congruence statements. You're going to use that to do problem number 10. Oh, sorry. 11, how many lines of symmetry does a regular heptagon have? So we can see that there is one here. So that's one. Two. 3, 4, 5, 6, 7. Go ahead and try number 12. 13, analyze the triangle shown. Triangle ABC was transformed to create A prime, B prime, C prime. Describe the transformations used to create the new triangle and represent the transformation using coordinate notation. So I feel like this is pretty easy to see. It's just a translation, and just to prove myself. Okay, maybe not. All right, I'm just going to show the translation. So it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, and then to the right 1, 2, 3, 4. So down 9, and then right 4. So that means in coordinate notation, we always start with x, y, and then that'll be x plus 4 because we did to the right, and then y minus 9 because we had to go down. Okay. All right, there we go. Try number 14. Okie dokie, artichoke. Number 15. Use the perpendicular bisector theorem to decide whether the diagram shows a reflection of the pre-image to form the image. Okay, so looking at this one, it's, first of all, babies, it says perpendicular bisector. Nothing on here is perpendicular, so that's a no. All right, we can tell because line T is not perpendicular to this segment right here, HH prime. Okay, we could say line or segment HH prime. It's a segment. All right, let's go ahead and try number 16. Number 17, describe the sequence of transformations that will carry BCD to B double prime, C double prime, D double prime. So first, we see that from the first to the second is a translation. And that translation is going up and to the right. And since it's not on a grid, we can't really tell the distance. So I'm just going to say up and to the right. And then after that, there's a reflection across this vertical line. Okay, go ahead and try number 18. Number 19, analyze this parallelogram, rotate about the origin 270 degrees counterclockwise, graph and label. All right, great, let's do it. Now, you can do the little trick I showed you where you outline it and then use the select tool to turn. You could do that, and we're gonna do that. But if you are unable to do that for whatever reason, right? because on a test you would not be able to do that unless you were using patty paper. The rule for 270 counterclockwise is y negative x. So you can use that rule to help you graph the new. So I'm going to show you how to do that. So the coordinates for G was that negative 7, 5. The coordinates for D, negative 5, 6. Let's see, negative 5, 3 for E. And then for F, negative 7, 2. So we could take all of those coordinates and do this. So switch the y and the x. Let me just do it over here. So switch the y and the x. So let's say we're doing point E. So we're going to switch the 5 and the 3, the negative 5 and the 3, and then we're going to change the sign of just the 5. So that's going to be positive 3, positive 5. Oops. Right here. And that will be the new E. So that would be at 3, 5. And then for point F, we do the same thing. Swap the 2 and the 7, but you're going to change this sign. So that would be 2, positive 7. Positive 2, positive 7. F prime. I'm going to move this out the way because I have a funny feeling that I'm going to need to move that out the way. All right, and then we got F. That was F, sorry. G. That would be at 5, 7. And then H would be, I'm sorry, what is it, G? D would be at 6, 5. And then we just connect them like so, like that. All right, so yeah, that's a possibility. So I'm going to go ahead and write those down, but then I'm going to go back and do the little rotation trick that we've been doing. Oops, forgot to put my little prime symbol over here for G and D. All right, so that's one way. Now we're going to try it a different way. We're going to start by outlining the original shape. Okay, and like that. I'm going to put the letters too, just because that'll help me keep track later. And I'm going to put prime, because those are going to be my primes. All right, fantastic. We're going to select with the box select tool. Select the entire coordinate plane as perfectly as possible. And we're doing 270 counterclockwise, right? Yup. So that'll be 90 counterclockwise, 180 counterclockwise, 270 counterclockwise. And that's where we ended up before, is it not? Just going to double check. D should be at 6, 5. Yep. So there you go. Those are your points. Put a little dot there to make it a little bit more pronounced. But yep, there you go. Go ahead and try number 20. 21, TDW was formed by reflecting LXP across the x-axis, which we can see over here. And write the congruent statement for the corresponding sides and angles. All right, so for the sides, we can clearly see that LP and TW are congruent. We can clearly see that WD and XP are congruent. So since I put P first and then X, I'll put W first, then D. And then lastly, LX. And since I put L first, that means T needs to go first. All right, there you go. And then the angles. All right, angle L matches with angle T. Okay. And then angle X matches with angle D. And then angle W and angle P are congruent. So angle P is congruent to angle W. LXP, TDW. Okay, good. Go ahead and take a look at number 22, which has nothing to do with 21. So use reflectional and rotational symmetry to describe the reflections and rotations that will carry the regular hexagon onto itself. Okay. So the rotational symmetry. All right, so in order for this hexagon to rotate onto itself, we need to figure out how many degrees it would take to do that. Okay, that did not come out as perfectly as I would have liked. C'est la vie. All right, so if I rotate this thing, I'm gonna do the best I can, y'all. Okay, a little bit off, but it's kind of difficult. All right, so if we rotate 60 degrees, the way you figure this out is you figure out how many sections this thing can be broken into from the center, and then divide 360 by that, right? Because all the way around this would be 360, so that means each of these has to be 360 divided by 6. So that's how I'm getting this 60 degrees. All right, and then every rotation of 60 degrees will result in the same, ignore that period, hexagon. So every time we rotate 60 degrees, it's going to match onto itself. The reflectional symmetry, a regular hexagon has 6 lines of symmetry, right? So let me get rid of all this. But if we're talking about through opposite vertices, so like if I go vertex to vertex, right, that's one line. Vertex to vertex, that's another line. Vertex to vertex, that's a third line. If I go through any more vertices, I've already created a line there. So there's 3 from vertex to vertex, and then 3 lines of symmetry are also going to be from side to side. So if I go from this side to this side, that's symmetrical, and that's 1. And if I go from this side to this side, that's 2. From this side to this side, that's 3. So it also has 3 lines of symmetry. Oh, sorry, it says 3 right there. Through opposite sides. And more specifically, it's going through the middle of these sides. All right, number 23, analyze the triangle shown. And I had to put it down here, sorry. Okay, I'll just move it up here for the time being. Oh, just kidding. It's going to make me put it there. All right, so part A is asking us to, or telling us, triangle ABC was transformed to create triangle A prime, B prime, C prime. Determine the transformation. All right, so this is the original. This is the new. And we can clearly see that there's some kind of rotation happening. So let's see if we can identify exactly what kind of rotation this is. So as usual, I'm going to outline this. Okay. And then I'm going to take my, hopefully this works because this is definitely a picture. Taking my select tool. I feel in my heart this isn't going to, oh, it worked. Oh, it's off center. I was like, what is happening? Okay. Sorry, this is not centered at all. Okay, let's see. I can do this. I believe in myself. There we go. Okay, I'm just gonna make a square. There we go. That's better. Okay, so what I ended up doing was creating a square. The thing is you have to create a square. And I created a square that made sure to touch the triangle I'm trying to rotate. So I did a square that's centered at the origin and it goes 3 in every direction. So yeah. All right, so that's a that's a clockwise rotation of 90 degrees. So let me write that down. So rotate triangle ABC 90 degrees clockwise. Okay, and then the next one, triangle. So this was supposed to say A prime, B prime, C prime was transformed to create triangle A double prime, B double prime, C double prime. Sorry about those mistakes. Determine the transformation used to create the double prime triangle. So it looks like it's just, no, it's not a translation, right? Because this is B and then this is B. So if I were to translate this, B is in the wrong spot. So this is clearly a reflection across the y-axis. So reflect triangle A prime, B prime, C prime across the y-axis. All right, lastly, how can you represent the transformation from triangle? Okay, so triangle, that should be A, B, C, to triangle A double prime, B double prime, C double prime using coordinate notation. So let's take a look. If we're gonna do a 90 clockwise rotation, so I'm gonna just do the first rotation first. Okay, so I'm doing this one first. Let me use different colors so you can see the difference. All right, so if I'm starting with that one, oh, sorry, that should have been. Okay, my bad. So I'm starting with that one. And then if I do 90 clockwise, that should be what? Positive y, negative x. Positive y, negative x. There we go. And then if I do reflect over the y-axis, that's going to be a reflection over the y-axis changes the x coordinate. So that'll be negative x comma y. Okay. So when we put those together, obviously this first part stays the same. When we put those together, the y, which is now the new x, becomes negative. So that's going to, so the y, which is the new x, becomes negative. So it was, the y switched to going first, and then we have to change the sign when we reflect. And then the x, which was already negative, it switched positions, so it went from first to second, and then nothing happens to it when we do the reflection, so we can just write it how it was. So actually, I don't know why I did that. That was silly. There we go.